Hello, I'm Dr. Papia Bhattacharjee. And in this problem, we have a function given, and the function is x squared minus 1 over x. And we also have the graph of the function right here. And we have to answer 3 questions. First, we have to figure out all the intervals where the function is continuous. So determine intervals where f is continuous, and then we will have to explain why. And then finally, we have to see if there is any discontinuity, and if there is a discontinuity, we have to identify which conditions of continuity are not satisfied. So if there is a discontinuity, why is there a discontinuity? Basically, that's what we have to say. Okay, so let's start from the beginning. Okay, so we have to figure out where the function is continuous. We can do it many different ways, but notice that we have the graph. So why don't we look at the graph of the function and see which x values give you some y values, right? Notice that the origin, whenever the graph is getting towards the origin, it's going upward on the left hand side, and from the right hand side is going down. So of course we can see this, the function is not even defined at 0. And if you look at the expression of the function, you can say the same thing, because the denominator of the function, this is a rational function, it has x. And so when x is 0, you will be dividing by 0. And therefore the function is not even defined at 0. And so of course, the function is not continuous there because it breaks, right? And therefore, the intervals where the function will be continuous, notice that for every x value to the left of 0, the function is continuous. It has a nice continuous graph. And to the right of 0, the same thing. It is a nice continuous graph. So the intervals where the function is continuous will be from negative infinity to 0, and from 0 to infinity, because 0 is not even in the domain of the function. And that will be our explanation here. Why is this function continuous only inside these intervals? Because the function, first of all, is rational. And for rational functions, they are continuous on its domain. And the domain of the function are these 2 intervals. So since f is rational, f is continuous on its domain. And the domain of the function, they are negative infinity to 0 and 0 to infinity. So that's the explanation why the function is continuous inside this interval. Now for the last part, the third part, we have to think about it a little bit. Is there a discontinuity? Well, of course the function is not continuous on the entire real line. It is not continuous at 0, and therefore 0 is a discontinuity. So yes, f is discontinuous at 0. So why is it discontinuous? What does continuity really mean? What is the definition of continuity? Let me remind you of the definition of continuity of a function. So suppose f is a function And we always talk about, at least at the beginning, we always talk about continuity at a point. So say f is continuous at a point C. And what does that mean? That means, first of all, f has to be defined at C. So f of C is defined. There is a value when you plug in C in the function. Second, when you take the limit of this function as x approaches C, that has to exist. And that actually means the left-hand limit and the right-hand limit exist and they're equal. That's when this limit exists. And the last, just these two is not enough. For continuity, we have to have that the limit is actually equal to the function value at C. So all three things together will make f continuous at C. So why don't we notice this value 0 and figure out which of these three is not satisfied? So number 1, is the function defined at 0? Of course not. We just described that, right? The function goes up and then starts down. At 0, there is no value because when you plug in 0, there is a 0 in the denominator. So number 1 condition is not satisfied. So f of 0 is not defined. Okay, how about number 2? Is the limit, so the limit as x is approaching to 0 of this function. What about the limit? Does the limit exist? Okay, let's look in the graph. So what about the left-hand limit? When the function, when x is approaching to 0 from left side, the function is approaching, going up and up and up. There is no value that the function is approaching to. It's actually going to infinity. Now when x is approaching to 0 from right-hand side, notice the function is going down. It's not going to a value. It's actually approaching to negative infinity. And therefore, the limit does not exist. So that fails as well. So the limit does not exist. And obviously, the third one will fail also. The limit does not exist, and there's no point for discussing that the two values are going to be equal because there are no values. So part 3 also fails. So all three conditions of continuity are not satisfied, and therefore the function is discontinuous at 0. Thank you.